Okay, this lesson is over evaluating a function. This standard says use function notation to build and evaluate linear functions for inputs in their domains and interpret statements that use function notation. That's the standard by the state. Okay, your warm-up, I went back to arithmetic sequences for your warm-up, and I'm going to kind of give you a quick review over that. Here is our sequence. Starting with the 10, 13, 16, 19, and I've asked you to find the recursive in the explicit formulas. All the recursive formula is a sub n equals a sub n minus 1 plus d. A sub n minus 1 meaning the term before a sub n. So all you got to do is look at the pattern, see that we're adding 3 each time, and write it with that inserted for the d. That is it. A sub n equals a sub n minus 1 plus 3. That is as simple as it gets for that. To do the explicit formula, to me it is easier to use y equals mx plus b and find the fictitious zero term. So if I'm adding 3 each time, that is my slope. That goes in place for the m, so I write 3x. And then to find my b, my starting point, that is actually where that's the zero term. It's the y-intercept, but in an arithmetic sequence, we don't have a zero term. So what we do is we add 3 to go this way, so to go back and find the zero term, we subtract 3. So that gives me 7. So y equals 3x plus 7, but to put it in the format that you need to for an arithmetic sequence, we write a sub n equals 3n plus 7. All right, function notation, that is read f of x. That is how we pronounce it. And it could be g of x, h of x, m of x, n of x. These parentheses do not indicate multiplication. F of 3 indicates the output of the function when 3 is the input. So 3 is the input, and then if we say f of 3 equals 25, that means that the input, whatever the input is, when I put it in, we have an output of 25. That's what that means. Okay, so if I'm looking at a graph and I want to find f of 3, I look at, because f of 3 stands in for x, f of x, I want to look at where x is 3. So I go over to the graph, this is what this means, x, the x value is 3. I go over to the graph, I find where x is 3, which is right here. I come up and I find that point. That point is right here, it is 3, 2. So when I'm looking for f of 3, my y value there is 2. That's the output. All right, if it asks me find x when f of x is negative 1, then I come over and I find where the y value is negative 1, which is right here. And this is 1, negative 1. That's the y value of negative 1. So the x value that corresponds to that is 1. Sorry for my coughing. I was fine until I started doing this video. So f of negative 2 equals what on a table? So I come over, again, this is my x value. So I come over to my x, which is negative 2, and I look at the y. That's negative 3, and that's the answer. The same thing if I'm looking for x, when I'm told that f of x is negative 3. So f of x, remember, is y. But I come over and I find, well, where f of x is negative 3, and it's negative 3 at negative 2, it's also negative 3 at 0. So there are 2 points where it's negative 3, so it's negative 2 and 0. Both of those would be true. All right, now if I'm finding f of 7 and I'm given this equation, I literally, remember, this means x. I just plug in 7 into this equation here and evaluate it. 10 times 7 is 70, plus 8 gives me 78. Then here, when they give me f of x, that's your answer. That's like being given your answer. F of x is 48. So I take this and I set it equal to 48, and I solve and I find the y value that makes that true. So, and if we've not done any of this year, but remember you subtract the 8, then here I would divide by 10, and that would give me 4. So the answer here is 4. And you have some work that goes along the same lines that this does.